In this video, we're looking at stretching graphs. So describe the stretch of the graph y equals f of x, or y equals f of 3x. So the change is inside the bracket, so it's changing the x's. And let's imagine that we have y equals x plus 1 squared as our original graph. So y equals x plus 1 squared. It crosses the x-axis when y is 0, and that's when x, or it touches it, when x is negative 1. So x is negative 1 there, and it's got a quadratic shape, so it's negative 1 here, and it's got 1, so when x equals 0, y is 1. If we change x into 3x, what happens? So we'll have y equals, so we're changing x into 3x, so it's 3x plus 1 squared. So what happens? So what value does x have to be for y to be equal to 0 now? It's now minus a third. So it's come in, it's moved in. And when x equals 0, y is still 1. So the graph has got squeezed in 3 times. So it's a third. Each x value is a third of what it was before. So when it says times by 3, we do the opposite and we divide by 3. So it's a stretch in the x direction, and the scale factor is 1/3. The second one, f of half x. So if we had half x, so if our original again was x plus 1 squared, we would have half x, we're changing x into half x, plus 1 squared. So what would make it equal to 0 now? What would make that bracket equal to 0? It would have to be negative 2. So that graph, it says half, we double. We do the opposite. It stretches out. The y coordinates stay the same, so it's still going to go through 1 here. So it's going to be at minus 2 here, stretched out like so. So it's a stretch in the x direction with a scale factor of 2. All the x coordinates double. So for the first one, all the x coordinates divide by 3. The second one, all the x coordinates double. So I'll write stretch in the x direction with a scale factor of 2. All of the x coordinates are doubled. When the change is outside the bracket, it changes the y. So change inside the bracket changes the x, outside the bracket changes the y, and it does what you'd expect it to when you change the y's. So again, if our original graph was y equals x plus 1 squared, if it's 2 times f of x, that's 2 times the whole function. It'll be 2 times x plus 1 squared. It will double all of the y coordinates. So I'm going to just do another drawing down here. So our original went through minus 1 and 1. So if we double all the y, it's going to go through 2 instead of 1. The x's stay the same, and all the y's are doubled. It's going to be twice as high. Each point will be twice as high as it was before. So it's a stretch in the y direction. With a scale factor of 2, exactly what you'd expect. And the last one, stretch in the y direction, scale factor 1/3. So all of the y coordinates are a third as high as they were originally. one for you to try. Pause the video, give it a go. So the first one, the change is outside the bracket, so it changes the y, and it does what you'd expect, times by 3. So all of the y coordinates are multiplied by 3. So we could say it's a stretch in the y direction with a scale factor of 3. The second one, again, outside the bracket, changes the y, does what you'd expect. So it's a stretch in the y direction with a scale factor of a 5th. So each point is a 5th as high as it was before. You're dividing all the y coordinates by 5, x coordinates stay the same. Part C, inside the bracket, changes the x, does the opposite. So it says times 4, you're going to divide by 4. So stretch x direction with a scale factor of a quarter. Each x coordinate will be a quarter of what it was originally. And part D, inside the bracket, changes the x's. It says a third, that multiplies each one by 3. So the scale factor is 3. So we've got f of x is x plus 2 times x minus 1. Part A says sketch it. So sketch y equals f of x. So y equals x plus 2 times x minus 1. Crosses x when y equals 0. When y is 0, what makes the bracket 0? It's negative 2 and positive 1. And when x is 0, what's y? 2 times negative 1, negative 2. Something like that. It's not perfect. Sketch the graph of y equals 2f of x, showing the points where the curve crosses the x's. So 2f of x will be 2 times the same graph. It's going to cross, when y equals 0, it's crossing at the same points. It's still at negative 2. And it's still at 1. But when x equals 0, we've got 2 times minus 1. So that's going to be at minus 4 now. So it's going to be the same graph, just all the y's are doubled. So it's going to come down a lot steeper. It's going to go down further. And then back up. F of x is x squared minus 1 now. Sketch f of x. So x squared minus 1 is the difference of 2 squares. It's x plus 1 times x minus 1. Crosses x when y equals 0. So that's going to be at positive 1 and negative 1. Crosses y when x equals 0. When x is 0, we've got negative 1. So we're just going to draw a quadratic shape. Like so. Sketch the graph of y equals 2f of x. So if you want to pause the video and have a go, do that. So 2f of x. I should have really left more room here. So I have negative 2 here, negative 1, and 1. So all the y coordinates have doubled. So negative 1 has gone to negative 2. And it's just the same quadratic shape. But every point will be twice as high as on the previous one. So if I was drawing it on the same graph, it would look something like this. Here's another one. F of x equals x plus 2 times x minus 1. Sketch f of x, firstly. So that's negative 2 and 1. And when x equals 0, it's negative 2. So that is our original graph. And we've got f of 2x. So we're changing all of the x's into 2x. So if I wanted the equation of the new one, it would be 2x plus 2 and 2x minus 1. It's a change to the x's, and they're all going to half. It's going to squeeze in. So probably best to do it on the same graph. So it's going to go through negative 1 and a half. The y stays the same. This minimum point's going to squeeze in as well. Going to be half as far over as it was previously. So it's going to look something like this. So it's squeezed in. Every x value is halved. It's squeezed in towards the axes, towards the y-axis. So if you want to pause the video and give this one a go. Our original is x plus 1 times x minus 1 again. So it's this shape going through negative 1, 1, and negative 1. That's y equals x squared minus 1. It's the x squared graph, moved down 1. You can think of it like that. Sketch the graph of f of 2x. So inside the bracket, changes the x's, does the opposite to what you'd expect. It halves. So it's halving all of the x values. It's going to be at minus a half and a half now. Crosses y at the same point, but all the x values have halved. Squeezed in towards the y-axis. And another one, f of x equals x squared minus 4. Sketch the graph of minus f of x, showing the points where the curve crosses the axes. So I'll draw the original first. So x squared minus 4. It's the x squared graph moved down 4 spaces. So it's at negative 4 here. You can also think of it as the difference of two squares. X plus 2 times x minus 2. So it's crossing at negative 2 and 2. When y equals 0, what makes the bracket 0? Negative 2 and 2. So minus f of x. It's outside the bracket. It changes the y. And it minuses everything. It changes all the positives to the negatives. So a positive y becomes a negative y. A negative y becomes a positive y. And if you want the equation, it's minus x plus 2 times x minus 2. So when x equals 0 now, it's going to be negative 1 times 2 times negative 2. It's going to be a positive 4 now. All of the positive y's are going to become negative. All the negative y's are going to become positive. So what's going to happen? It's going to make a reflection. Where we had negative y's, they're positive. Where we had positive y's, now they are negative. One for you to try, so give that one a go. So let's sketch the original first. So it's the reciprocal graph. So the original looks like this. We want minus f of x. So for the equation, it's going to become minus 1 over x. It's going to become the negative reciprocal. So all of these negative y's are going to become positive. It's like a reflected over the x-axis. all of these positive y's become negative. Here's another one. F of x is x times x minus 2 now. Sketch the graph of y equals f of minus x. So the negative is inside the bracket this time, so it's going to change the x's. Let's sketch the original. So y equals x times x minus 2. When y equals 0, x can be 0 and 2. And when x equals 0, y is 0 as well. It's going through the origin. So our original graph looks like this. If we've got f of minus x, the equation would be, so all the x's change into negative x's. It would be negative x times negative x minus 2. Now, when y equals 0, x would have to be negative 2 to make that 0. All of the positive x's become negative, and all of the negative x's become positive. It's like a reflection over the y-axis this time. So it looks like that. Some people might say, why is it not doing the opposite to what you'd expect? But multiplying by -1 and dividing by -1 are the same thing. So it says multiply by -1. You could say we divide by -1, but that has the same result. So all the positive x's become negative, all the negative x's become positive. One for you to try. Pause the video and give it a go. So we've got a cubic this time. So our original, when y is 0, what is x? So we've got -1, we've got a repeated root at -1, and 2. It's a positive cubic, so it's coming from the bottom. Touches the repeated root and goes back up. And when x is 0, we're going to have 1 squared times -2. That's -2. So that's our original graph. We've got f of negative x. So the positive x's become negative. So this 2 is going to become -2. The negative x's become positive. Our -1 is going to become 1. And it's still going to be going through the y at the same place. Y stays the same. So it's a reflection. So just imagine it flipped over. So it came up on this side, touched at the 1, that's the repeated root, went back down, and then up through 2. So it should look like a reflection. If you wanted the equation of this, so you have to change all the x's into negative x. That would be y equals -x plus 1 squared times -x minus 2. And if you wanted to make that look nicer, you could take the negative, factorize a -1 out of this bracket and move it to the front. So have a negative on the front. And write this as 1 minus x. So have 1 minus x squared times x plus 2. So you can see that it becomes a negative cubic because you've got a negative times negative times a negative, which is 3 negatives times together, which becomes negative. And you can see that it goes through 1 and -2, with 1 being the repeated root.